Hello everyone, I am Sahil Sawant and currently I am pursuing my M.Tech in Computer Engineering at VJTI Mumbai with a background in Electronics and Telecommunication and research experience in RF systems and radio astronomy. In my previous episodes, we discussed something very important. A signal is a variation that carries information. We understood signals as physical phenomena, voltage variation, pressure variation, and electromagnetic field variation. We stayed away from the heavy equations. But today we step into something very deeper. Today's question is, if signals are just variations over time, why do engineers move away from time? Why do we transform signals into frequency? And why does Fourier exist? Look at this example signal. It looks messy, irregular, and complex. Now I ask you, what frequencies are present in this signal? From time domain plot alone, it isn't obvious. Time domain can tell you when something happens, amplitude variation, and the signal shape. But it does not clearly tell us what frequencies exist and how much of each frequency exists. And in engineering, frequency is what matters the most. Why? Because systems respond differently to different frequencies. Let us say you are tuning a radio. Multiple FM stations are broadcasting simultaneously. In time domain, your antenna receives a superposition of all the signals. It looks chaotic, but in frequency domain, each station appears at a different frequency band. Frequency domain separates what time domain is mixing. That is powerful. Here's the revolutionary idea given by Joseph Fourier. Any periodic signal can be expressed as a sum of sine and cosine waves. That means even the most complicated waveform is just combination of simple oscillations. Think of musical chord. When we hear a chord, it sounds like a single continuous sound, but it's actually multiple notes combined. Frequency domain is like separating each node from the chord. The time domain shows the chord. Frequency domain shows the individual notes of the chord. Imagine a signal made of 5 Hz sine wave, 15 Hz sine wave, and 40 Hz sine wave. In time domain, you see one complicated waveform. But in frequency domain, we see 3 different spikes. One at 5 Hz, one at 15 Hz, and the last one at 40 Hz. That's it. The chaos becomes the structure. Fourier does not change the signal, it changes how we are supposed to look at it. In engineering, we often deal with filters, communication channels, antennas, noise, amplifiers. And here's something critical message. Most systems behave differently depending on the frequency. For example, a low pass filter blocks high frequencies. A speaker has a limited bandwidth. An antenna will resonate only at certain amount of frequencies. If you stay in time domain, you cannot easily predict how a system will behave. Frequency domain makes system behavior simpler to analyze. When we apply Fourier transform, we are converting signal as a function of time into signal as a function of frequency. Time tells us when did it happen. Frequency tells us what oscillations are present. Both are equally real and equally important as well. Both describe the same signal, just from two different perspectives. Let me connect this to something I have worked on. In radio astronomy, when we observe solar radio bursts, the raw signal in time domain looks noisy and weak. But when we transform it into frequency domain, the pattern emerges. These specific frequency bands light up. We can identify it as emission peaks, interference, or spectral signatures. Without Fourier analysis, much of radio astronomy would never have existed. Fourier is not just mathematics, it is a scientific lens. Frequency domain is powerful, but time domain is not useless. Time domain is better for transient detection, pulse timing, and sudden spikes, or control systems as well. Engineering is about choosing a right perspective, not worshipping a one single domain. In episode 1, we saw what signal really is. In episode 2, we saw signals have hidden structure and Fourier is the thing that is going to reveal it. In the next episode, we will go into something more dangerous, that is the sampling. What happens when engineers are sampling signals incorrectly? What is aliasing? Why do systems fail because of it? There's where mistakes begin. And we will explore that in the upcoming topic. Welcome back to Signals and Stars. Until then, have a good day. Hello everyone, I am Sahil